Oh, there we go. Walk away from the speaker just a little bit. Hello and welcome to United Astronomy Clubs of New Jersey.
It's kind of muffled. Yeah.
Nope, nope. It's usually like that. It just happens to be uh, this voice pack. All
Oh,
right, but
oh.
welcome up here to, like I said, United Astronomy Clubs of New Jersey in Jenny Jump State Park in Hope, New Jersey. So it looks like we have a number of people just filtering down from parking tonight. So I'll give them a couple minutes to get down here and get settled. I do want to welcome you all who are joining us not only here, but also online on Twitch and YouTube, because that is right. We do live stream these to both Twitch and YouTube. If you happen to be there, do hit those like, follow, subscribe, the free actions, letting us know we're doing a good job. In addition, you can check us out on our website, which is probably how many of you found us. It's uacnj.org, and you're going to find many things, such as our list of upcoming talks, list of talks we've had in the past, as well as lists of our member clubs, because the best way to actually get it started in astronomy is to join your local astronomy club, and what better way to find yours than look up on a list. In addition, you can check us out on our social media. We have Facebook, Instagram, we have a Discord server, all great places to find what we're up to, as well as any special events that we may have going, or even just ask questions or share pictures you may be taking. We are a nonprofit, so all even just showing up, signing in on our sign-in sheet, like I said, hitting like and subscribe does help us out, and we have been able to offer these free programs for very many years, thanks to everyone's donations being able to keep paying the bills. And as Dan says, I should stop saying keep the lights on. We are astronomy based. We want the lights off at night. With that, it looks like most of us are actually down here and settled. So it is time to give you guys the safety briefing. If you need to use the restroom, that is the porta potty in the back. It is big, it is blue. It is illuminated by a red light in the dark for ease of finding. Although it will get dark a little later because yesterday was actually the summer solstice, which is the longest day of the year and therefore the shortest night of the year. We also have a little museum and gift shop area that you can feel free to check out. This time I do have someone helping me out, so I don't need to be in two places at once. So Rosanna's in there and she'll be able to help you out and answer any questions. After the presentation, we do have a number of scopes open. I don't know which ones, but in each of those buildings with the roll-off roofs houses its own telescope. So feel free to go up and ask the astronomers who have the telescopes open what they're looking at after the presentation. In addition, when we go to leave, we do want to use our headlights. We do not want to run people over. We do not want to get run over. It's just way more hassle and paperwork than it's worth, and let's stay out of the hospital. And that being said, any flashlights we may have or light sources like our cell phones, do try and keep any light pointed towards the ground because we don't need to accidentally blind people by holding flashlight raves. Those sick tricks are great, but this is not the time or place for those. So, you're not here to actually listen to me babble on. You're here for our presentation tonight, given by Karl Hricko. His talk tonight is from Stonehenge to the Webb Space Telescope. Karl received a doctorate degree in Science and Humanities from Rutgers University. He was the Science Department Chair and taught Earth Science and Biology at Carteret High School, as well as being an adjunct professor elsewhere. He has been past president of astronomy clubs, but continues to conduct science programs on WNTI and makes presentation on science topics. He began a National Space Society chapter in New Jersey and became a space ambassador for NSS. He has used the Tubble, the Hubble Space Telescope, and currently has a podcast called Carl's Orbit. And with that, here is Carl.
Well, welcome everybody. Good to see everybody here. And as a matter of fact, maybe you might be thinking about joining some kind of amateur astronomy club, and then you can join the UACNJ, which is an umbrella organization for all the astronomy clubs in New Jersey. So I hope some of you are thinking about that kind of thing to do. Now, I'm going to have a commercial going here. Uh, I'm a member of the National Space Society as well, and we have a chapter here in New Jersey. And if you want to access information about the NSS, National Space Society, you could just access our website and find out how to join the NSS, or you can join the chapter. Don't have to be a member of the parent organization. You could join the chapter only, and we don't charge any dues. So that's a nice thing about it as far as I'm concerned anyway. So the NSS, which is an organization to explore, develop, and settle space like the moon and Mars. That's what it's set up for. Chapters all over the world, as a matter of fact. England, India included. And this is the idea of our chapter. There we are. That would be the Space and Astronomy Society of Northwest Jersey. If you're interested in that, just stop over to see me afterwards, after the presentation. That's me. That's my name. Belongs to me, obviously. And the idea is we're going to go from Stonehenge to the Webb. Interesting kind of a transition. Amazing. It takes into account the history of astronomy to a certain extent. Unfortunately, I have two versions. I didn't bring the one that's shorter, so I'm going to have to go over some parts of this in terms of some of the print that's on it. I didn't mean to have that. It doesn't fit within the concept of going maybe 45 to an hour. So I'm going to go over some of the print if you don't mind. Pardon me for that as I go through this. But it's interesting to note that people in the past have looked up at the sky as being a very important thing for existence. Their survival depended upon looking at different kinds of objects in the sky, and these early civilizations used these stars and planets. And by the way, the planets were looked upon as being stars. Everything was a star, and that was heaven, a special place. Nobody could go there. It had to be perfect. And so therefore, anything that moved in the sky had to move in perfect circles, because a circle is a perfect geometric form. So this is the idea then. The early civilizations used the sky watching to provide them with information to keep time, to predict the future, to harvest their crops, for fertility, for navigation purposes, North Star and so forth, and also for the idea of combining it with their religious practices. So this was all combined together in their culture. It wasn't something separate. We have a tendency to have special kind of studies of different specific areas. We branch off and study them in depth. At that time, everything was included when they looked up at the sky, at the heavens. Had no TV, obviously, no cell phones. Wow, hey, imagine that, no cell phone? You couldn't survive, right? No cell phone. Suppose your cell phone was taken away. Uh-oh, you're in trouble already. So they looked at the stars in the sky and developed patterns, which we call constellations. In order to make sense of whatever was up there, they made figures, animals and humans and gods and stuff like that, forming the constellations, which we still have on the basis of the original Greek names for the constellations. And besides the constellations, You also have the idea of how the stars move. The North Star doesn't move, obviously, because our axis of rotation points to the North Star. And so that's like a sweet spot up there. In some of the cultures, they believe that that was the center of heaven because it didn't move, since our axis points to it. But there are all the other stars around it begin to move. And as they move, they can be used as a clock, especially those that don't appear to set. They just appear to be there and circle around the North Star. And they're located there. The Big Dipper is such a constellation. And that's what they use. They also use markers. They were good at that. Either they had a stone that they used, a special stone that was already in place, like something like this, or it could be a building. They use maybe the orientation of the building, maybe a window frame, that part of that frame aimed at that part of the sky where during summer solstice or winter or the equinoxes, the sun rose and the sun set. They were markers in time to tell them when the season is changing. That was their calendar to a certain extent as well. That's why their survival was based on that. So here's a stone. Stone is used to observe as a pointer to the moon, obviously, placed within maybe another structure, like this is what's called a heel stone, in the middle of some of the gigantic stones making up Stonehenge. Looking at the eclipse, maybe of the sun, which was an amazing thing because who controlled the apparent disappearance of the sun? It was looked upon as being an event that was something where the sun was disappearing, and so there were celebrations and rituals to bring the sun back. And whoever was having knowledge of a coming eclipse, which they believe the Stonehenge did predict, by the way, once they got the Stonehenge in place, they were able to predict, they think, various kinds of events and phenomena, like the solar and the lunar eclipses as well. And so they use various kinds of astronomical tools. As you see here, different kinds of civilizations, the Aztecs, the Mayans, those in the Stone Age, in terms of, you can see Stonehenge. They use different kinds of monuments. They made discs that acted as planispheres of where the stars were in the heaven. And it was surprising. They found some disc, maybe you'll see it later, it should be in this presentation, that was picked up, dated back to the Stone Age. It acted like a planisphere. Planisphere is a star wheel. Maybe you've seen it, maybe not, but it's made of cardboard or made of plastic or whatever else might be the case. Theirs is made of stone. So this looks like Stonehenge would look from the sky. It first began as a ditch, and they put various kinds of markers in a ditch in a circle, because in a circle it makes it easy to mark anything in the sky. All you have to do is pick two of the markers in the circle across, and that would be your direction to look at that event, wherever it might be. So it acted as an alignment device, so you can align it to the target that you're looking at. Then later on, as time went on, Stonehenge was built step by step, phase by phase, centuries by centuries. It wasn't there all of a sudden where they brought in the stone. It went through these phases where first there was a ditch marked with maybe chalk type of stones. Then it was marked with wood columns, wood poles. Then finally replaced by stone over several kinds of centuries. So it was a long-term process, Stonehenge. Here would be Stonehenge now, showing the alignments, different stones as they mark the sky. In terms of, on the right, you can see sunrise at summer solstice and winter solstice, and at the bottom you can see sunset at the same time. So they marked the time of the year with this calendric system in terms of using Stonehenge as a calendar as it went by. These were all over the place, all over the United Kingdom, Ireland, Scotland, England. Not only Stonehenge, there were these stone circles all over the place, but Stonehenge was the most prominent one of them. Here's that disc I was talking about. This was dated back to the Stone Age, and on the left you can see various kinds of markings. You can see the Pleiades marked, and other kind of stars as well. to see what it looked like. And of course, the idea was to observe the motion of the planets in the sky. Some civilizations looked at the planets primarily, other civilizations looked at stars. Now, the Chinese looked at the stars primarily. The Indian culture looked at both of them, but they were looking at this information. As a matter of fact, there is a present kind of structure in India involving, as you can see here, some kind of marking device that acted as a kind of a sundial, so you know the time of the day. Now, these were the first pyramids that were built, for example, in the Mesopotamia system area, which was made up of Babylonia, Sumeria, Akkadia, Assyria. And what it was a step type of pyramid. So the first types that were built in steps. And they were built first by the Mesopotamians. Then the Egyptians picked it up and built their own. This is the one built by the Egyptians. They started out with a step type of a pyramid, something like this, until they decided later to cover it, to make it smoother, so that the people can go to heaven more easily along a smooth surface than a bumpy surface, because it served as a kind of a sacred structure in which they bury their pharaohs, as you probably know. So here's the major pyramid at Giza, the Plateau of Giza in Egypt. And it was the one built for the pharaoh Cheops, or Khufu. It was the largest one, as a matter of fact. And these were used as markers as well, to mark the heavens. As a matter of fact, one of the major constellations in the sky, which they named differently, was the constellation we call Orion the Hunter. And you can see now the 3 stars in the belt of Orion. Theirs was Osiris. They looked at it this way. Here's an artist's conception of how possibly they could have seen Osiris, their major god, in the heavens. So our present Orion the Hunter, for them, was Osiris, their major male god. And of course, the male god had a queen. And a queen was the bright star Sirius for us in the sky right now. And that would be Isis. And they fashioned various kinds of statuettes in terms of their gods. This carried on the culture of Osiris and Isis. And here's how it would look, for example, if you connected the stars making up Orion the Hunter for us. We could see that the 3 stars in the belt of Orion point right to his queen, Isis, on the left, which is our star, Sirius, in the major dog constellation, Canis Major. So again, all these things were observed in the sky in terms of that. Now, the major pyramid again of Cheops or Khufu was used as a marker. Here's a diagram showing that they had shafts in it, not only for ventilation, but the shafts served the purpose of aiming at the North Star, which is a very special place in the sky, as I mentioned before, in terms of being a very sweet spot, only staying there and not moving. So they wanted to have a shaft pointed at that North Star. It was very important for them in their religion. And also another shaft pointed to that part of the sky where the bright star Sirius came over, telling them that the season was changing. The bright star being our Sirius, and their queen, Isis. So it was used for that purpose. Now the Chinese also had a very important idea of watching the motion of the planets in the sky as well, to mark the heavens for them. And they noticed this: in 1054, there was a supernova explosion that they recorded. It was a star located in the constellation Taurus. And now we see it as this: the Crab Nebula. It was a supernova, so it was labeled as SN 1054. And we can see this in Taurus now, where the star that exploded, all the gases and dust moving out into space, moving further and further out. An exploding star recorded by the Chinese. They made these kind of star maps as well, with their constellations on here, by different names, of course, as a calendar system for themselves. And also, we have the same thing occurring in the Arab culture as well, where they came up with a model that was a planetary model to tell where the planets were, and also the phases of the moon. They had that marked, they had that down. And also, they had their globes. They marked their celestial globes in terms of where the stars were in the heaven, made a sphere out of it, just like we have a celestial sphere as well. Don't know if you've ever seen one of these celestial spheres that we have that mark everything in the sky as far as we know, but it shows where things are located. And that's what they were doing as well. And the same thing is true of making this device, an astrolabe, which was served for the purpose of navigation and also for locating various kinds of objects in the sky using the degree of separation from each other. Now, in Mesoamerica, now moving to Mesoamerica, which involves Mexico, Central America, and also South America, we have this Machu Picchu, the Inca culture, set up buildings in a very special place that served as a religious sort of location for them to visit and to notice various kinds of things happening in the sky. They had a special building that marked again, and this was always marked, it seemed, summer solstice, the rising and setting of the sun. Came in through a window, went across a shaft, cast a shadow in the building in a very special place so that they could mark the beginning of the summer solstice. Machu Picchu, Inca culture, Mesoamerica. Here's a map showing Machu Picchu. And also, if you see the green sort of area that's part of Central America, you can see it shoot out. The Yucatan Peninsula shoots out there, and in it you have areas that also contain various kinds of structures that mark the heavens. Chichen Itza is one of them, and in Chichen Itza you have different kinds of buildings. The Caracol is one building, and there are other buildings as well that mark various kinds of celestial events occurring. Now, I'm going to have to go through several of these very quickly because otherwise this presentation will last so long. That's why I mentioned before, this is the long version. So I'm going to go through a lot of these areas and just mention the highlights, if you'll forgive me for doing that. But here's a map of an area which is called Teotihuacan. It's like a culture that existed between the Mayans and the Aztecs. I had a chance to visit that on one of my jaunts, and it was very interesting. When the Aztecs took it over after Teotihuacans had left the scene and had died off as a culture, the Aztecs took it over and made a street called the Avenue of the Dead, where unfortunately that's where they sacrificed their victims. They made the Temple of the Sun and Temple of the Moon, again, recording things happening in the heaven. And so there's various maps showing this Teotihuacan culture. Let me go through that quickly. Now this building here, you can see, had various kinds of levels, and each level there were openings, windows that marked the rising and setting, mostly of Venus, because the Mayans really used Venus as one of their gods. So it's very important for them to mark where Venus was in the sky at any one point in time. They had to know where it was. And so they use these buildings to do that. Here's something I visited, quite interesting. You wouldn't think so. Someone said, hey, let's go and visit an observatory. Oh, all right. So we went on the bus, visited this place. And what it was we kept on going down instead of up. It was a cave in which they had an opening, a tube to the surface. And in the tube, they had the rocks within the tube itself, leaving an opening. They were jutting out in the tube at different angles. And allegedly, it was supposed to act as a magnifier, as a lens. So they call it the zenith tube. It marked, again, the idea of solstice positions and things like that when the sun passed overhead, noontime and things of that nature. So that was quite interesting, I thought. And of course, these cultures mark their heavens with various kinds of calendric system. The Aztec calendar, the Mayans had a calendar. And then we switch now to the area here in the USA where our Native Americans set up various kinds of structures as well. Here's what's known as the medicine wheel in Wyoming. And what it is, a bunch of chalk marks and indentations in the ground forming a wheel. And the wheel served as a marking device to point in any direction they wanted to point it. It was also connected to their religious practices, where they would go to the medicine wheel at a higher altitude it was located, and they did their religious practices there. So it was all over the place. I mean, there were, I don't think there was a culture that didn't practice the observation of the heavens in this sense, from Stonehenge leading on to what we have now with different satellite telescopes in the sky, space telescopes in the sky. And then it goes on in terms of other kinds of observation of the sky that's made. Here's something that served, it's called a kiva, K-I-V-A. It was a religious kind of building where they had the religious practices. And again, it had an opening where the sun was allowed to come in, cast a shadow on the opposite wall that was marked for the summer solstice. So even the Native Americans, in the form of the ancient Anasazis at that time in our western area, marked the sky. And interestingly enough, that same supernova explosion that was marked by the Chinese, 1054, was also marked by the Native American Indians in one of these buildings that they had there. Here's the building, and there's the picture of it. You might see what looks like a star in the center of that, it's called a pictogram, where they marked it. They made a picture of it. So they marked also the supernova explosion in 1054. Watching the heavens, always watching the heavens. So let me go on, maybe bypass a lot of this. Not necessary. I'm sorry I have to do this, but now the Greeks, let me get to the major Greek here. Aristotle introduced the idea of an earth-centered kind of universe. So everything went around the earth. And it was picked up, that idea was picked up by an astronomer by the name of Ptolemy. Let me get to Ptolemy and skip all these Greeks here. Let me go back just to show you this. And by the way, one of the problems they had, the Greeks, and everybody had at this time, is that when you observe the planets in the sky, Mars and Jupiter, the closest ones to us, and there were 5 visible planets, right? Mercury, Venus, and Mars, Jupiter, Saturn. Only 5 visibles. And as a result, as you watch the planets, it had this motion in the sky called retrograde motion. They couldn't explain it. And so when they tried to come up with a model of how the planets worked, sun and planets going around us, that was hard to do. They had to make up contrivances that satisfied that problem. Let me go by this quickly. And so what they came up with was the Earth-centered, called geocentric kind of model with all the planets going around. But what they had to do is they had to make the planets themselves, besides going in orbit, they had to make them going in circles on the orbit called epicycles. And that kind of solved the problem of why the planets had that backward motion every so often, called retrograde motion. But not quite. So they had to have these epicycles. Now Ptolemy came on the scene, picked up Aristotle's idea and went along with the epicycles. You can see here. That's the important point I want to bring out, the idea of the epicycles. And so they had to keep doing this in order to satisfy the motion of these planets. Along came Copernicus, much later, as a matter, by the 1500s. And what he did is, I think he looked at some of the Greeks, because there was a ancient Greek astronomer who came up with somewhat of an idea of the sun being at the center. Aristarchus was his name, but it wasn't accepted. They went along with Ptolemy with the Earth being at the center up until the time of Copernicus. What Copernicus did is he put the sun at the center. He was a religious cleric, as a matter of fact. So his ideas were not accepted in the beginning, because it was for people to think of the Earth as being an important place. And if it's in an important place, it has to be at the center. You don't want to drop that idea. You want to get rid of that idea. We're so important, we have to be at the center of everything. And so what they believed up until this time was that the Earth was at the center, not the sun. He put the sun at the center. That caused a kind of a stir. But it solved the problem of retrograde motion. They were saying that if all the planets went around the sun, it was like a racetrack. And so some planets were going around that were nearer and going faster. And so it seemed that as they looked at the planets, they were falling back and then going forward again as you turned around the curve, going faster. That's what he discovered. So he got rid of that retrograde motion idea anyway. But he still had some of the epicycles. He had to keep them because he still had the planets going in circular orbits. And they don't go in circular orbits. They go in elliptical orbits. No one knew that at the time. Don't forget, they were perfect, and perfection was a circle in terms of a geometric form. So anyway, he solved the problem of that retrograde motion. And then along came Galileo. Galileo did not invent a telescope. He used it to look at the heavens, because before that time, I don't have the picture here, a guy named Lippershey seemed to have invented the telescope. He was a Dutchman, a Dutch optic maker. And then what Galileo did is he used a telescope to point to the heavens, because before that time the telescope was used by the city-states in Italy to see if any enemy kind of boat was coming at a distance. It was used for that kind of purpose. A spyglass, they used to call them. Only for that purpose. Galileo, let me see what's up there. And he did. He saw a lot of things up there, by the way. He saw information, for example, I'll mention a few. First of all, let me see if I have any here. I should have them here, although this is the long version, as I mentioned. Okay, let me mention what they are. He saw the moons of Jupiter. He saw them going around Jupiter. He didn't see all the moons of Jupiter. We have, what, about 30-something moons, and counting. They're still finding moons. But he discovered the 4 largest moons of Jupiter. They were named after him as the Galilean moons. And let's see if I named Io, Europa, Ganymede, and Callisto. I remember it because I remember the phrase, "I enjoy good coffee." And that keeps me in mind of what the names are of the 4 Galilean moons that Galileo discovered. That's amazing. 4 moons going. Now, if they were going around Jupiter, that meant that everything wasn't going around the Earth. So that was evidence already coming in now, actual visual evidence that we're not at the center. He was backing Copernicus's idea by actual observation, which Copernicus did not do. So here we are now, the 4 moons of Jupiter. Discovered that idea. And he also observed, here's how he saw Saturn on the left at the bottom there. he saw them and he called them ears on the planet because he didn't know that there were rings going around Saturn. And of course, we see Saturn that way now. Now, what else? He also discovered the craters on the moon. And again, at that time, everything up there was heaven. That's what we still call the heavens, but we don't mean it's a special religious place anymore. Although some people say, I'm going to heaven, and they point up. Well, anyway, heaven up there, made up the planets and stars, is a physical location, and it had to be perfect. And the moon had to be perfect, obviously. But here he spotted these potholes on the moon we call craters. He thought they were bodies of water because they looked dark. And so he called them mares in Latin, or seas. We still call them seas, but that's not where the water is on Mars. We now know there is water on, not Mars, I meant to say the moon. We now know there's water on the moon, and they're located in some of these craters, are protected from sunlight. They don't melt. And if we go to the moon, which we plan to do, we'll be landing essentially at the south pole of the moon. That's how they have it planned, because that's where most of the water is located in the form of ice in some of the craters. They've determined that already, so they know. But at that time, Galileo thought it was water, seas on the moon. But he spotted these craters as well, pockmarks. That was the idea in terms of the craters on the moon. He also observed sunspots. And there's talk about the idea that it kind of caused him to lose his vision later on, because I don't think he was using protection at the time. They weren't aware that the sun would cause damage, injury to the eye. You should never look at the sun directly, by the way. Children have maybe some kind of idea of looking at the sun every so often. I've come across some who have done that as a kind of a challenge, and not a good idea. Anyway, he saw sunspots, blemishes on the sun, something wrong there too. And as he went on, he spotted just a few more things. He noticed that Venus, which is in between its orbit is between us and the sun, has phases it goes through. He noticed phases of Venus as well. There can't be phases of Venus unless it's going around the sun and not us. Good evidence, again, that we're not at the center, but the sun is at the center. So he spotted that as well. Then after him came an astronomer, Tycho Brahe. And what he did is he came up with the idea that there's a combination of the idea of a geocentric and we call the sun being at the center heliocentric, geo-heliocentric system, which never worked, by the way. But he never used a telescope. He never used a telescope. He used a kind of a sextant, a tremendously huge, actually a quadrant. Let me go on with this. I'm going to go over a few things here. Okay. And then along came the idea, after Tycho Brahe, we have the idea of Newton, Isaac Newton. And you're familiar with Newton to a certain extent. Well, you probably heard about Newton's laws of motion. Right? The idea of first one being inertia, second one being an equation in terms of force being the product of mass and acceleration, F equals ma. The third being action-reaction. So laws of motion. Universal law of gravity, he came up with that as well. And he came up with the first telescope that used mirrors, a reflecting telescope. So essentially, there's two basic types of telescopes, refracting and reflecting. Refracting would use lenses and is using lenses, and reflecting uses mirrors as well. So you can make your telescope shorter, since you can bounce the light back and forth in the telescope using mirrors, making the telescope shorter than would be possible with the refracting telescope using lenses, long tubes. And he came up with the idea of planetary orbits as well, gravity, universal gravity. That was important for Newton. Had a formula for that as well in terms of one object attracting another. And by the way, as you now know, or may not know, uh, Einstein has changed the universal law of gravity. Not the universal law of gravity, but the idea of gravity itself. And let me go on with this. So Newton had that. He did that, among other things. Let me go over this. I'm going over it quickly because there's a lot of things here that are not necessary. Laws of motion. I told you what the laws of motion were. And we have telescopes now being built after Newton built his reflecting telescope. Other telescopes like this refracting telescope at Yerkes Observatory, located in the area of Wisconsin. That's refracting telescope. And the Mount Palomar telescope in California, large one, 200-inch. It was the biggest for a while. Now we're getting into high technology. We're moving from simply observing things in the sky visually. Now we're seeing more than 5 planets, obviously. So we can see technology changing our whole notion of our universe. We're no longer, are we the center? We're just a planet going around the sun. Our sun is not at the center of our galaxy. We're not the only galaxy. It's many of galaxies found in the universe, and there might be more than one universe. So along comes Edwin Hubble. He started out being a lawyer, but then he changed, and he came up with his Hubble law in terms of there being a connection between distance and velocity. He observed galaxies in the sky, and he noticed the galaxies based on determining their distance and motion on using what they call redshift, where there's a change in light when something travels a long distance. If it starts out being blue, short wavelength, it turns to red, being long wavelength, called redshift. They use that to determine distance. He came up with his formula that the velocity, the speed of a galaxy in space, is connected to its distance. And he came up with how fast it's going on a basis of a constant he called the Hubble constant, which they're still trying to figure out what it really is. They're having trouble with that. Anyway, he was the first to make a classification of galaxies, the first to come up with Hubble's law and Hubble's constant, as I mentioned. So he contributed quite a bit to astronomy. And so as a result, they named one of the first space telescopes the Hubble Space Telescope, which looks at only mostly visual objects in the sky. And it's located at an orbit around the Earth. Here's some of the images. I'll go through quickly. Taken by the Hubble. Images of stars exploding. Images of stars forming, star-forming regions. Galaxies. Planets. Beautiful objects in the sky. You should check this on the web. You can see various kinds of objects being shown on the web in terms of this. Now, we get to the Webb telescope. Now, this is a comparison between the Webb telescope, which is located at a point 1,000,000 miles away from the Earth, not like the Hubble. The Hubble is close to the Earth, in orbit around the Earth. The James Webb telescope now is 1,000,000 miles away, so if something goes wrong, it can't be repaired. We have no way to get to it necessarily. That makes it convenient. So it had to be corrected. On the left is an image taken by another space telescope called Spitzer, worked in infrared mostly, wavelength of infrared, not visible light. On the right is the James Webb telescope of the same area. Notice the difference between the two kinds of views, one by the Spitzer and one by the James Webb. The James Webb goes back to 180 million years after the Big Bang. That's close to the Big Bang so far, going back that far. So it's getting there, but it'll never get to the Big Bang. There are reasons for that as well. Oh, I don't want to show you. This is something I had on here. Someone took an image, and it looks like a face, right, doesn't it? On Mars. Actually, it's just a cliff after NASA went by again. All right, looking at the Hubble. Oh, he's the guy that controls the Hubble. And this is the end of the presentation. And the idea is going from Stonehenge to James Webb was quite a distance in time and in technology. Our whole world has changed in terms of our view of our universe. What's up there, how it works, so on and so forth. And keep in mind, don't forget, we no longer think of astrology as being a valid kind of practice. Astrology is the study, of course, of how the planets, the moon, the sun, and so forth, the stars affect our lives and control our characters and can serve as a predicting device. Not good, not true. Astronomy is looking at things working physically in terms of how far away they are, how fast they're traveling, what they're made of, so on and so forth. Quite a difference between astronomy and astrology. So know that difference at any rate. So this is how things have changed from Stonehenge to the James Webb Telescope. By the way, look at some of the images taken by the James Webb Telescope. I want to mention one more thing. The James Webb has come up with images that bring the objects like the galaxies so close to the Big Bang, like I mentioned, about 180 million years away from the Big Bang. Even at that time, we're not supposed to have fully formed galaxies based on our present model of how the galaxies have evolved in our universe since the Big Bang. So it's contradicting our present model of the Big Bang and how the galaxies has evolved. The James Webb is coming up with all kinds of contradictions, which means that astronomers will have to look at what their model is of how the universe is evolving. That's what the James Webb is doing right now, coming up with weird objects, red objects they're calling them. They don't know what they are. They think there might be black holes forming into galaxies. They're not sure. But all this happening almost just after the Big Bang should not be the case on the basis of our present idea. So check James Webb Telescope online as to their present images. Very interesting. Very interesting. Thank you.
All right. Thank you, Carl, for a great talk. Thank you, everyone here. So we are going to be doing a question and answer session. What I'm going to do for people here, if you have a question, you're going to raise your hand and keep it raised and kind of wave it around like you don't care as it gets darker because my vision is... Come on, stop that.
I have questions. No, I don't have any questions here. I have no answers.
Sorry, my headset's being a little funky tonight. But you're going to wave your hand around and keep it up until I get to you with the handheld mic so that the people online can also hear your question. Because chances are, if you have a question, someone else online might have that same question, or even here might have the same question and might not be brave enough to ask it. Online people, you have it easy. You get to just type it in chat, and I monitor those to my handheld portable internet. All right, but first, because I do know a couple people snuck in during the presentation, and this safety briefing will be unescapable. Just a reminder, if you need to use the restroom, that is the porta potty in the back, it is illuminated by red for ease of finding. We also have a little museum and gift shop area you can check out. I do have one of my volunteers there manning the desk in there who will be more than happy to answer any questions. We also have a couple telescopes open, so you, as it gets dark, should be able to see stuff as we find holes in the clouds, because there is some cloud cover. So it'll depend on what's available through those holes in the clouds, like I said. So I'm going to start things off with a question online, and that question is, what is Carl's favorite historical period of astronomy?
Let me think on that one. Very quickly, I'll come up with the idea of our present day. Because
Yes.
we have the James Webb up there, and it is getting a fantastic amount of new information, really new, breaking the barrier of physics, as a matter of fact. Really, check it out.
All right, was a question all the way in the back. I'll go to the hand I saw up first. You put your hand down, you cease to exist. There you are.
What scope is stronger?
The question was, what telescope is stronger, a refractor or a reflector?
Oh, I don't think you can really contrast them in terms of which one is stronger. And I imagine the question deals with the magnification of it. You got the same magnification, although now most of the, I think all, well, obviously all of the space telescopes, which by the way are in orbit, as I mentioned, about 1 million miles away from us, at one of the 5 points between us and the sun, and 5 points between us and the moon, called Lagrange points, L points for short. L1, 2, 3, 4, 5. L2 is the most stable. You can pop something up there, it'll stay there actually, because of the combination of the equality of the gravity between us and the sun, and the centrifugal force of the object you sent up there. So that's where the James Webb Telescope is, at L2.
So, to give you a little more detail, refractor or reflector, one or the other, really isn't better, like overall, than the other. It depends on what you're doing. Just much like anything in life, even if you were to buy a cell phone, a computer, a camera, a gaming system, what you want to do with it matters. One of the big advantages of a reflector is it can be more portable. So if you want to go out to random places and state parks and national parks and use that telescope, reflector might be a good choice. We do have a number of different scopes, some of which are reflectors, some of which are refractors, some of which actually have a combination of both mirrors and lens optics. I don't, like I said, I don't know which ones I have open right now, but some are better for planetary, some are better for those deep sky objects that are way out there. So again, the best thing, if you're looking for, especially if you're asking this because you're looking to get a telescope, is to find your local clubs, look through as many telescopes as you can, and kind of make an informed decision from there. Right, and I see another question back there. And again, you put your hand down, you disappeared. Oh, cute pupper.
How do we even know that the Big Bang is why everything is a thing?
How do we know that the Big Bang was made everything exist?
Well, the idea being that when Edwin Hubble looked through his telescope, he observed the galaxies moving away, moving away. So he figured that if they're moving away, they could be moving from someplace that was a central point from which they originated or came from. And so the idea then is that it should have been a Big Bang. But now there's a modification of that. Now some of the astrophysicists are coming up with the idea that there might have been more than one Big Bang occurring throughout the whole universe. And now I came across somebody else who believes that there's a series of Big Bangs still going on right now at this very moment. So there's different ideas then that not only may there have been one Big Bang, but maybe there were many Big Bangs, and more so, many Big Bangs still going on now at the present time, so quick that we have a hard time telling it's happening, discerning it. And that eliminates, by the way, that theory eliminates the need for dark matter and dark energy, if you know anything about that.
So basically, we don't know 100% for sure, but it's the one of the more likely scenarios given the information we have collected thus far. So hopefully eventually we'll unlock those secrets, but maybe when you go through college you can answer some of those questions yourself. And I know we had a follow-up question over here.
Yeah, well, the follow up was kind of what he already answered, because I did see like an article recently that said the Big Bang Theory is wrong, but not necessarily that it's like completely fabricated, just it's a bit misunderstood. And of course, we don't know 100%. But my question, and once again, thank you so much for the presentation. Kind of just looking into the future of space exploration in our solar system. When do you realistically think humans will step foot on Mars? And my follow up to that also is, do you think it would be harder to step foot or to travel to another planet in our solar system? Or do you think it would be harder to travel to another moon or another asteroid? Like, which one do you think would be like the hardest?
Well, the hardest would be the furthest one, of course. The easiest one would be the moon, which is why I think that a settlement, if any, is to be started, should be started on the moon first, because that way we can learn more about how to live in an environment that is completely alien to us, nothing like the Earth. We have to carry our environment with us in some fashion or other, any place we go beyond the Earth. And they're having a problem with the idea of being on board the space station in terms of even being that close to the Earth. There's a problem with being exposed to radiation, causing difficulty in terms of human physiology. Also, the idea of microgravity causes a problem. It gets so deeply into it that our chromosomes are affected by being in space beyond the Earth. There are structures at the base of our chromosomes called telomeres, which act as caps, like a cap on a shoelace, that prevents the DNA from unraveling. Well, they're affected, and they have been affecting people. Matter of fact, there were twin astronauts, one on Earth, one went on board the space station, the Kelly twins. And when the Kelly twin came back, it was discovered that the telomeres on the chromosomes were affected in his case. So there are problems that have to be solved first before we decide to make a settlement any place on any kind of object in space, any celestial object.
And just like anything, getting someplace, whether it's the moon or Mars, is as difficult as we want to make it. When we were landing people on the moon with the Apollo programs, we were going, this looks like the best option available, the easiest place to land. And still, you hear the stories and the recollections of how when they were coming down in the lunar lander, that they had to manually take control and go, let's not land on the jagged rocks. Let's go over here to where it's more flat. Right now, we have a lot of people trying to land stuff on the moon near the poles, which is much harder. So again, it's how hard do we want to make it on ourselves? and sometimes that's a bigger factor of, are we getting in our own way of being successful? So that's also something to keep in mind. Our next online our next online question is, did they have coffee back in Galileo's time?
Coffee?
Yes, coffee. And I realized I said that with a horrible New York accent, thanks to my mother.
Maybe they had something that served as coffee, but I don't know if they had coffee beans from which they make the coffee that we're familiar with. I'm not sure about that one. But what connection it has to astronomy, I'm having difficulty with.
I think you had made a comment that involved coffee.
Oh, you mean the acronym? Okay,
Yeah,
the phrase that serves the purpose of helping me to a memory aid of sorts in terms of I enjoy good coffee. I for Io, E for Europa, G for Ganymede, C for Callisto, the four Galilean moons. Okay,
yes, now I remember
now
that
I got it.
section.
Okay. Yeah, there's coffee on those moons, by the way. It's
There,
called moon coffee.
there will be when a human gets there, because I can almost guarantee you, wherever we decide to land a man next, they're going to probably be stocked with coffee. Okay, did we have another question out here? I know I saw a number of hands earlier, but again, it gets dark. Really? No questions? Just crickets? At least we have crickets, and it's not horribly raining today. I am going to give online people warning. Any last minute questions, do get those in. I see someone went to lurk because they want to order dinner, which is completely understandable. Dinner is an important part of every day.
I'm sorry, I don't serve dinner here.
Yeah, it would be nice, but I don't want to keep the certifications to be able to serve food. Like I said, any questions? If you have, we have another one over here.
Gee, nothing.
Hi, thank you
yeah.
for that once again. Kind of just talking about a very hot topic right now with artificial intelligence. How do you see AI crafting the future of the astronomy industry when it comes to space exploration, and specifically data relating to our telescopes and you know, the rapid rate at which technology is improving? Like, how do you see AI kind of taking part into this entire mission? And do you think that at a certain point it'll sort of make the job of humans obsolete, or do you think there's always going to be an element of the human touch when it comes to exploring the cosmos, looking at big sets of data, and trying to just observe more about stars outside of our solar system, planets, nebulas, etc.? Like, how do you see AI really affecting that?
Let me get my tarot cards out. Wait a moment. No, the idea would be, in my mind at any rate, that AI is going to be here and it's going to develop into some things that we can not even imagine right now. And I suppose the first thing, and it is being done right now, as a matter of fact, as you probably know, where it's being used to process data. There's so much data gathered in terms of astronomy that astronomers can't keep track of it. As a matter of fact, there are programs called citizen science programs that you might want to look into to take part in as a citizen scientist, actually, because they can't handle it. There's so much data. So I can see the AI moving in to improve computers now with the whole new world of quantum physics. Wow, that's opening up a whole doorway of something unimaginable. And that will take part as well in the whole area of AI rather, artificial intelligence. So data has got to be done first. And then what happens is that well, automatic kinds of processes have got to be developed, and AI will be involved in that. and the idea of being replaced by various kinds of non-human devices, that will be done to a certain extent in terms of heavy-duty jobs. If we want to establish, say, a colony somewhere in space, we'll need the help of different kind of robotic devices in order to make our lives easier and more manageable, and things of that nature. So we'll have use of automatic robotic devices, which will involve artificial intelligence, obviously to a certain extent. Whether or not they'll be humanoid type is another story too. But I guess uh, because of the psychological effect of us being better able to work with mechanical devices, robotic devices, more mechanical, well, beyond mechanical in terms of, say, digital. In order to do that, psychologically, it's easier to work with something looking human than something not looking human. So we'll have, I guess, a supply of those as well. There'll be a mix. Now, whether or not they'll take our place eventually, don't know. It depends how we control the technology. It seems uh, our organizations and our different institutes have a hard time keeping up with the development of technology. It takes a while before our legal system catches up with it. All our different kind of institutes have a hard time keeping up with technology, but eventually they will. And we'll have control to a certain extent is my hope for the future.
And a thing to keep in mind with any technology, it is only as good as the user you or the builder behind it, and it is only as good as the data you put in.
Mm.
If you give, like, if you have an iPad, you can do an amazing amount of stuff with it when you're 30. If you give an iPad to a 5-year-old, they can do an amazing amount of stuff because they've watched you. But that stuff is much simpler and less complex. Usually they're watching YouTube videos. Yes, there's a reason why we have parental controls and disable the Amazon ordering. Always a good thing. Even to do, I put that on for myself so I don't accidentally one-click order stuff as I'm perusing through looking for socks.
Imagine having robotic children in the future.
But so it's only as good as the instructions you can give it. Like I said, so the instructions you can give a computer as a 30-year-old are much different than the instructions you can give it as a 5-year-old. Second, it's only as good as the data you could also give it. So, great example are little robot vacuum pucks that many people have. When Roombas first came out, they were only bump sensors and very inefficient in cleaning. As the technology has progressed, we now have added extra sensors. We have LiDAR, we have the bump sensors, we have and that all that data is much better that we're feeding it, so it's much more efficient at cleaning. So the data we put into it also matters. So we still have a ways to go before we have a true robots making robots, no human intervention at any point situation. So I think we're a ways away from the iRobot apocalypse.
Well, we fooled them. I'll read a hologram.
All right. Any last minute questions? Perfect.
Hello. I had a question about the images from the Webb telescope.
Yes.
Are they colorized? Because does the telescope, are those the real images, or are they colorized to show some different wavelengths that are not visible?
Well, it's showing red objects that they have a problem with explaining what the origin and their nature, and so the red color in that image, I would imagine, would be the actual color itself. So I think the images coming in from the James Webb essentially are actual images and not colorized. I might be wrong, but that's my impression.
Yeah, I think there are sections, much like the Hubble, where you can go in and look at the untouched data images versus the images that people have taken and gone, oh, I want to boost where I know I've decided oxygen is blue, and boosted those levels. There's filtering that commonly people do. So I would imagine that there is untouched data out there, but much like the Hubble, there is also data that people have edited. And perhaps some of the things you might see in Times Magazine might more likely to be edited than something you would see in a research paper. So that also might depend on the source you get that image from. And I think I see a question back there.
Are all planets are no two planets identical, or are they like snowflakes? Like none of them are the same.
Snowflakes. No. Well, there is a situation where, for example, initially they discovered that Venus was about the same size as the Earth, so it was given the title the Earth's twin planet. But the whole environment is quite different. So in that sense, the planets are different from each other. That's an interesting point, by the way. That's quite interesting to note that they are quite different. Because they're in a different location of space, and they're subject to being bombarded by a different kind of object. For example, you have the asteroid belt between Mars and Jupiter, and so those two planets are bombarded, and their whole geological structure changes as a result as compared to the other planets. And it depends where they formed, how far away from the sun. Some formed where they got rid of their atmosphere to a great extent, and all they have is the rocky surface with a very minimal atmosphere, like Mars, for example. But on the other case, further away, there's less sunlight and less chance for the atmosphere to burn off, so to speak, and be gone. So they held on to their atmosphere of helium and hydrogen, like what's called the gas giants. That would be Jupiter, Uranus, and Neptune. So it depends where they are when the solar system formed, and how they're influenced by whatever is around them, like the asteroid belt objects, the asteroids, and so forth.
All right. So I'm going to take two last questions, just because it is getting slightly dark, and people are. You need to remember, I'm like the Jurassic Park T-Rex. My vision's based on movement in the dark. Otherwise, you're just kind of shadowy figures without my distance glasses, which I have left somewhere. I'm sure I'll find those later. So I'm going to get this guy right in front.
When did the James Webb launch into space?
When did I'm sorry, I missed that.
When did the James Webb
Oh, James
telescope
Webb.
launch into space?
Ooh, I don't have the date. I'm sorry. I don't have that answer specifically. Don't have the date marked down when it was. There has been many different types of space telescopes that have been launched. So there's a whole series of dates for all these space telescopes. There's about like 20 or more space telescopes located at those different Lagrange L points between us and the sun, essentially. Don't know if any are in a position between us and the moon at those L points, but there's quite a few up there. And as a result, it's hard to memorize the dates when each one of them were launched. So that I would have a chart for, just like I don't know all the elements on the periodic table either.
Right. Carl will be available to answer questions after this as well. I'm going to take this last question during the presentation, and then...
I have 3 questions.
Three?
One.
Wow, you're not
Okay.
messing around. 3 questions. Okay.
Do you think we'll have any vacations to the moon?
Vacations? Well, I'll tell you, before we have vacations to the moon, you know, there are companies now that are establishing a condition so that they can have space tourism as their marketplace. So putting up various kinds of space hotels that would be in low Earth orbit, that you could visit a hotel orbiting the Earth if you had enough money, if you had a rich uncle or something like that. So they intend to do that. Uh, let me see. The idea of Virgin Galactic is one of them, a company that is planning on conducting space tourism. So we do have that taking place right now, as a matter of fact. Not that it's in place, but there are plans for it, and they're moving in that direction.
Right, like I said, Carl will be available for a bit to answer some questions. I just want to make sure we wrap up the program for the night. I do want to thank you all who have joined us here in Jenny Jump State Park and on our Twitch and YouTube channel. If there are questions for like our online people, or you guys go home and think, man, I wish I had asked that question, do feel free. We save these presentations on YouTube. You can always ask the question in the comment of this archive video once it gets uploaded to YouTube. Or even, like I said, hit us up on those social media, Facebook, Instagram. We have a Discord server. Great places to get those questions answered. And with that, thank you, Carl, for a great talk.
Oh,
Thank
you're welcome.
you, everyone who has joined us. Clear seeing and good skies
Thank you for
for
coming.
tonight.